Okay, good morning, ladies and gentlemen. Please, the panelists come up to the podium.
Nice to see you. Hey, Julius. Thanks for the nice call out to the NSF. Appreciate that. Yes. Thank you.
We have the panel on the future of wireless. We have 8 distinguished panelists. These are Julius Knapp from the Office of Engineering and Technology of FCC, who just gave the presentation, the keynote presentation. We are really delighted to have Jalal Mapar, who just arrived this morning from the West Coast, given his tight schedule, managing the transition to the new administration. We are really delighted to have him. We have from the Department of Homeland Security. We have Thyaga Nandagopal from NSF. We have Joe Paradiso from the MIT Lincoln Lab, Media Lab, Media Lab. We have Ted Rappaport from New York University. We have Tom Sawanobori from CTIA, and we have Ed Tiedemann from Qualcomm, and also I added Chih-Lin from China Mobile. So actually, we did not expect Jalal to show up because of his schedule, but he was really kind and surprised us, and we are really happy that he came. So what we'll do, in fact, in this panel, we'll have maybe a 2-3 minute presentation, or maybe, yes, with or without, in fact, slides about the position of each speaker, and then we'll move on to some questions, and then we'll open up the floor for questions and answers. So I'll start with you if you have anything to say.
They've heard enough from me.
Okay, thank you so much. So, Jalal, please.
Good morning. I wasn't supposed to be here. Thank you very much for having me here. My name is Jalal Mapar. I'm with the Department of Homeland Security Science and Technology Directorate, where we focus entirely on the science and technology to support the department. If you're not familiar with DHS, just a few numbers for you, just like Julius told you about FCC. DHS was stood up based on the Homeland Security Act of 2002. We're almost 15 years old. We're very young, a very young department. The third largest government agency behind DOD and Veterans Administration, about 235,000 plus employees, consisting of, depending on how you count it, 22, 23 components that we refer to. Some of the names you might be familiar with: Coast Guard, FEMA, Customs Border Protection, Immigration, Customs Services, and then of course we've got these Secret Service and so on. And then to support the entire department, there's a Science and Technology Directorate that is similar to what DARPA is to DOD, but our time horizon tends to be on a shorter scale. So we support all of the research and development activities in all of the portfolios, whether it's wireless communications, whether it's sensors, whether it's software, cyber, et cetera. That's what we do for the department. From a bigger perspective, DHS has got a huge responsibility for ensuring the resiliency and protection of our cyber infrastructure, both from all different aspects of IT, OT. We also talk about things related to cyber physical security. That is a marriage of physical security and cyber security. And then, of course, on top of that, one of the areas that I'll talk briefly relates to keeping the critical infrastructure safe, secure, and resilient. And many of you are familiar with what the structure looks like, but remember, for example, the electric grid is part of the critical infrastructure and one of the top priorities for the nation. And as we talk about those things in terms of things that relate to the conference you might be interested in terms of wireless, the future of wireless, IT, OT, CPS, however you want to define it. You're dealing with SCADA, and then all of a sudden the combination of things just goes out of proportion. So that is an area that is a priority for us, just to make sure that we understand what's going on. It gets into cascading effects, interdependencies, what the future looks like, devices. Julius mentioned about the explosive number of devices growing, standards, and so on. So just to give you some ideas about some of the things that we do, and I'd be more than happy to answer any questions you might have.
Yeah. So at the NSF, we fund, just looking at the topics covered at GLOBECOM in the program and the associated symposia, we invest close to $100 million every year in these related topics in terms of funding basic research on these subjects, not to mention many of the commercialization and tech transfer opportunities from many of the other programs that we support. But one of the salient, since 5G and wireless is a big theme overall these days, right? So we do have a brand new effort that's called, that Julius also alluded to in one of his slides. It's called the Advanced Wireless Research Initiative. Specifically, we are targeting the building of 4 large-scale, what we call a city-scale testing platforms that will enable cutting-edge wireless research, not just in the cellular-focused context, now 5G, or also the entire heterogeneous network ecosystem that will be created, not in the wireless, Wi-Fi, sensors, the back end, the core network, and so on. So this is a major effort that we are undertaking, just starting now. We expect to see the first few platforms to go up in about a year's time, a year and a half from now. And if you're interested, many of you have probably heard about this. If not, feel free to reach out to me for specific questions, and I'll be happy to talk to you more about that stuff. Now, that said, the field of wireless is much more bigger than 5G, and I think we'll keep hearing this theme repeated again and again. Julius had this wonderful slide about IoT in the end, where you saw the cellular IoT or the wide area WAN IoT taking one corner, and there's 3 different other pieces which have much bigger user base that are already in practice right now, and they're already in there. They're not waiting for any standards. There are already other standards that are being used for those, and it's something that we need to keep in mind as we think through what are the big problems. One of the challenges that NSF, as people looking forward towards funding priorities, is sometimes people get carried away with the latest buzzword, and it's very important to always remember the big picture as to who needs this stuff and why would they use something like this. So 5G is good, it has a lot of potential, but again, we also need to be aware that there's a world outside of 5G that will a lot of people relate to. How many of you have 4G IoT devices? Show of hands. Right, see, I thought, a few, right? How many of you have Fitbits or some Nest thermostats in your house? Yeah, much bigger set of hands, right? So, it's we need to be aware of how the ecosystem overall, and then see what the needs are and how these new things that we are trying to do will help address those needs. So that's a big picture that I'll probably return to again during the questions.
Good morning. I'm Joe Paradiso from the MIT Media Lab, where I run the Responsive Environments Group. We look at how sensors and sensor networks and sensors everywhere connect to people in different ways. There is certainly an explosion of sensors in IoT. I think all of you know this. It's been discussed in different ways today. Sensors are propagating into every device that Julius basically showed in his slide earlier in his keynote. And there are more and more devices that are wireless, and everything has sensing. Data is flowing from everywhere. And I think we're reaching a world where the user interface that we experience right now, it's on a device like this, or perhaps this laptop. It's going to be decentralized. Sensor data flows up into the cloud. Context comes down to guide things that happen. We're not going to be running apps. We're not going to have our hand on controls. A lot of things will start to happen for us, and wireless sensor data is what's going to enable that whole revolution. This platform that we all know, and a lot of this conference is about the cell phone, we see as being dead at the Media Lab, more or less. It's halfway through its cycle of computing. Already Apple is taking out the headphone jack. Soon the whole thing will be something that may be somewhere on your body, but you won't take out and look at necessarily unless you really have to. We're going to enter the era of wearable computing and infrastructure computing. So the data will appear on things that we wear. Already, I've got messages on my watch, soon it will be up here as well, or in the infrastructure, sensor data also, wearable and infrastructure. So this whole decentralized world is coming very, very fast. In terms of devices, we're seeing extremely high integration now, right? We certainly get a capable radio processor on a single die that's commodity now, but some will have energy harvesting on the same die as well. So this little device, this potentially chip, will harvest energy, at least condition the power, have radio, and have sensors, everything together. Sensors that can harvest energy will be passively powered because there's a huge RF power initiative, or at least wireless power initiatives. A lot of it is inductive at this point. Hasn't really caught. I think the future in all of this is going to be low power sensors that can scavenge energy but have to have energy beamed to it. So these things will come. For instance, I had a leak in my ceiling. Contractors couldn't find it. I had to have half of the ceiling ripped out to be able to find the leak. Why didn't the wall board have little sensors embedded I could just scan with my wireless powered device and show me where the leak is? It's easy to do. You can do it at very low cost. We call it sensor tape. So these kinds of things will happen. Also, body sensor networks for wearables. Julius talked a bit about implantables. We see that as the user interface of the extreme future, which may not be so extreme, especially if anybody has medical issues. This is the present. Getting power through the body as well as wireless through the body using bands that are amenable to that. That's going to be a certainly more and more important issue. Also, wireless as a sensor, not just as communication. Multipath and artifacts are something we all have to deal with in communications, but there's information in that. And people have started to exploit that at a whole new level now. At MIT, we have Fidel Adib, who just joined the Media Lab, by the way, and Dina Katabi at CSAIL doing great work with using multipath and artifacts to track people around a room and even look at their respiration and heartbeat without wearing anything. So wireless as a sensor is coming. Certainly also embedded radars, we see them in cars. Google solely shows you radar embedded into something like a phone for UI. So this is going to be something that we'll see more and more of as well. And of course, I'm a big believer in the next big sensor for IoT being indoor location. I think I'm speaking to the crowd here. Once we know where you are indoors to within centimeters, lots of things can happen, from smart lighting to smart heating to things appearing where you're paying your attention, so on and so forth. This, of course, will come with wireless. UWB will probably play a role in this. Fusion with other sensors, so on and so forth. So my laundry list. Thank you.
Good morning, everyone. I'm Ted Rappaport with New York University and NYU Wireless. It's great to be here, and thank you, Julie, for that great keynote. Joe and I are the only two professors on this panel, and I know most of you are either professors or students here at the conference, so we kind of represent the academic side. And as an academic in wireless research, I, just like everyone here, really work to create a culture and an environment where our students, primarily our graduate students, have an opportunity to not only see where industry is building its future, but also to help move industry to the future. So we try to, at NYU Wireless, involve companies from all over the world who are very interested in having a lot of bright and hungry students work to solve problems that are just too tough to solve in industry. And our goal is to be 5 to 8 years ahead of where the market is, so that when a student finishes their PhD, they're really able to go in and contribute to the emerging standards and the emerging vision that industry will have based on their work. As an academic also, we're very grateful to people like Thyaga and Julie, who are in public service, who are offering the funding and the competitive meritocracy that allows our students and colleagues to apply for the federal funds. And without the support of the federal government in the US, the research enterprise and conferences like this wouldn't exist. So the federal funding and the opportunity to work with other professors at other universities to build collaborative teams and to expose the graduate students to those teams while exposing them to the leaders in industry is so vital to perpetuate the industry 10 and 20 years forward. So that's what I think Joe and I and all of us in academia really strive to do. At NYU Wireless, our major focus is understanding the future, what I call the renaissance of wireless, the ubiquity of broadband wireless communications. And thanks to the FCC's leadership around the world, you see us going from a spectrum scarcity world to a spectrum glut, where 29 gigahertz of spectrum is on the table for wireless. Really unprecedented. It's really the start of a whole new world, a whole new society based on wireless devices such as the ones Joe just mentioned in the sensor area. But in order to build the future semiconductors and to build the systems and to understand the capabilities, it's vital to have fundamental radio propagation and antenna studies, basic channel models, modulation and coding expertise, information theory, really understanding what I call the PHY and MAC layers of wireless, and then to bring together faculty that also know the network layer and understand the application layer. And that's what we try to do at NYU Wireless, and are very fortunate to have the support of 16 major industrial affiliates and NSF. And I think the FCC has done something which is really we're at a remarkable point in time in history for wireless communications. It's about to become as pervasive as electricity, indoor plumbing, running water all over the world. By opening up these huge spectrum bandwidths, it's going to push the engineering feats throughout the world and open up the eyes of governments to really bring information to every part of the world. And without this major spectrum policy, I don't think you'd see it expand as rapidly as it's going to. So we're in for a very exciting time, and as academia, our goal is to prepare the students for this very, very rapid change that's about to happen.
Great, thanks for your remarks, Ted, and thank you, Bijan, and the rest of the panel for the opportunity. I'm Tom Sawanobori, Chief Technology Officer for CTIA. We're an industry association based here in Washington, D.C., right down the street. And we represent over 200 members of the wireless industry, primarily in the United States, with our U.S. operators, along with technology companies that are represented globally. Qualcomm, Ericsson, Nokia, Intel, many others, device suppliers, technology suppliers, infrastructure suppliers. And I'm pleased to have the opportunity to talk to you today, kind of representing our perspective, along with those from academia working on the FCC and advanced research initiatives. So I want to talk a little bit about kind of where we are today. So if you can put up the first slide on 4G LTE. And I think we take it for granted a little bit about what we've done so far. So just to kind of bring you up to speed on where we are today with the investments that the operators have made and the ecosystem and the industry have provided. Here in the US, we are a global leader in 4G LTE. Started in 2010, over 5 years ago, and pretty much all the national deployments are completed. This is the first time in the United States that everybody's been on the same major technology, 4G LTE, and that's a major accomplishment in and of itself. We've deployed coverage to a vast amount of Americans, and that continues to be expanded into the various nooks and crannies, both in rural areas as well as into urban areas and indoors. We're continuing to advance the technology, moving into LTE Advanced with very, very high speeds, using advanced technologies we'll talk about on the panel, like advanced modulation techniques, massive MIMO, carrier aggregation, giving peak speeds into the hundreds of megabits per second and approaching a gigabit per second. But it's not just about speed, it's about innovation as well. And we brought new services to bear, capabilities like voice over LTE, which are many people are using in the US today, but are also going to be foundational for new services that will be built on top of that. New video services and new innovative offerings from our operators, and things that are going to happen that we don't even expect. I mean, I don't think any of us expected augmented reality like Pokemon Go. It was just using today's technology just became kind of an overnight success. And there'll be more and more things that'll be coming out, and some of us won't even get all these things, but there'll be things for the next generations. But we're not standing still. We're also not only working kind of upstream to do more and more capabilities, we're also working to enable the Internet of Things. So recently, some of these new categories of devices, Cat M and Cat Narrowband, are opening up capabilities for Internet of Things. And that enables things that some of the other panelists have talked about, that Joe talked about, sensors, because you need low power, more cost-effective chips and capabilities to enable those sensors, those energy capabilities, the smart home devices, the smart city enablers. And those are things that are going to open up things. So we're continuing to press on advancing the LTE technologies, but we're not standing still. And we're moving into 5G. So if I could have the next slide, please. And what are the major benefits of 5G? We're going to talk a lot about, over this conference, what technology capabilities go into this. Ted's research and many others on millimeter wave technologies. What's it going to bring to us? It's going to bring, first of all, very, very high speed capabilities, very, very fast, right? So that'll provide a lot of capacity. Studies that we've done and forecasts have shown that usage is growing sixfold by the end of the decade. And a new Ericsson mobility report that just came out last month said that usage is going to increase 8 times between now and 2022. 8 times, and we already have a massive amount of usage today on the network. So you think about that, and we're going to need that spectrum that Julian and others and NTIA are working to make available for us. So we're going to have very, very high speeds, and what's that going to enable? More capacity, but we're also going to have more capabilities for ultra-high definition video, for virtual reality, which is just on the cusp of taking off, for that augmented reality. We're going to have latencies that are 5 to 10 times better, response times that are much better for real-time robotic applications, industrial Internet of Things, things that we are just imagining, and we're developing use cases for those in industry forums. And then we'll be able to support, even though IoT is really happening significantly on today's technologies and with LTE, in the long run we'll need 5G for massive Internet of Things, where we have just a huge number of wearable devices, sensors, tags on everything. If you can imagine a massive amount, particularly in urban areas where there's a lot of people, where there's a lot of city population. So we're working, our operators and members are working on the 3GPP standards very aggressively on getting 5G standards developed. All of our national operators, Verizon, AT&T, T-Mobile, Sprint, and even US Cellular are all testing and trialing 5G technologies, not just one location, but multiple locations. Some are testing the technology to see how it's going to work and experimenting, and others are working towards making commercial tests and viability to see what can be the best service offerings, whether it's fixed wireless or whether it's mobile, and we'll need the support of the entire industry and the ecosystem to make that a reality. So I think combined, what are the key enablers that are going to be important for us? Can I have the next slide, please? So we're definitely going to need infrastructure placement, and it's important that we get, especially as we look towards the cities, to have to speed up the deployment of small cells. We'll need access to municipal facilities, we'll need reasonable costs in doing so, and we'll need streamlined permitting. And I know that sounds sort of all very reasonable, but these things are things that our cities and municipalities, states, and even our federal government are going to need to help us support as we move forward, so we can keep up with that massive growth and we can really get the networks deployed in order to support the usage. And we'll need a vast amount of and different bands of spectrum. So we will need those low and mid bands that Julie talked about, but we'll also need those high bands. To be able to deliver on the promise of 5G, we'll need those high bands, and we're thankful for the FCC to take rapid action in record time for making the Spectrum Frontiers order in place, creating that certainty for industry leaders to now go develop equipment and to be able to move forward. And we haven't figured everything out, but we're going to work with the industry to help resolve and better understand and characterize and perfect 5G technology. So together we can make 5G a reality in the US, and we can continue to be a global leader. So thanks for your attention.
Okay, thank you. Good morning. I'm Ed Tiedemann. I hope everyone had the opportunity to listen to my keynote yesterday, so I'll try to focus on a few little aspects. Back when I was a little kid, we talked about ubiquity of communications. That was like everybody having a phone in their house and maybe not a party line in their house. Okay, today we're at really a new era of ubiquity of communications, and that is really connecting everything with communications. The IoT, I talked yesterday about the number of devices that are appearing in everyone's household today, being north of 20 devices per household that's being connected. It's tremendous. Not only that, our usage patterns are changing significantly. We no longer are content to wait for content to come to us, i.e. the thing that when I was a kid, everybody went to the TV for like the nightly news or the Wonderful World of Disney or something like that. We want it now. We want it on our platform that we have on us when we want it. So we have a lot of challenges here. I mean, we have to look at where does, for example, TV and broadcasting go in the world, okay? In the US, we're taking some steps on that. Europe is taking some steps on that. But there's a whole different thinking of the way things work, information gets transferred, and all of that's really coming about and changing as a result of technology. The other thing that's really happening out there is I see a convergence of technologies. Anybody can say, gee, we have the cellular type technology, we have the Wi-Fi technology, but we're seeing a convergence. In fact, it's actually happening a little bit quicker than I actually expected. Part of that is coming from the use of Wi-Fi technology, okay, is carrying a large amount of the bits out there. Not necessarily the coverage, but the large amount of bits. But then those who are operating Wi-Fi systems and things like that want a lot of the capabilities and the features and the things that really work well on cellular. Like, hey, I got my connectivity all the time. I don't have to go through web pages or as in this hotel, seemingly to wait about 5 minutes so I can actually enter the password or something like that because, well, enough said. But that's what people want, and that's what we're going. So we're seeing this convergence, and it's happening in, for example, the interaction between the 802.11 group, for example, and the 3GPP group, where they're trying to make enhancements on the network side, which 3GPP is doing to better incorporate Wi-Fi technology. We're also seeing, of course, the 3GPP type technologies now being more deployable in the unlicensed spectrums and such. So we talked a lot about this. And of course, we're going now into the big area of 5G, which is, to me, fundamentally a new platform. And the new platform is learning the lessons of a lot of what we did for basically the 4G era. But I always have to caution us that when we did 3G, one of the slides that I presented back in 1997, actually during the beginnings of 3G, was what about the internet? And I presented this to an ITU thing, okay? Because everybody was still in the mode of circuit switched services. And of course, from our perspective at Qualcomm and my perspective, data was all about connectivity to the internet. Now that proved itself out a few years later. But we also didn't understand at that point the concept of the camera phone didn't exist until we basically had the 3G stuff done. The smartphone did not exist until we had the 4G standards essentially done. We don't know yet what's going to happen, what new ideas will be out here for 5G. So we have to create this general platform, and we hope that it will fit the applications that will be appearing in the future. And we create these platforms, and cleverer people than I, or perhaps younger people who have, thinking in new dimensions, okay, will come up with some really great things. And then I'd like to end with the concept, the issue of spectrum, because this is really one of the critical things that exist. And it's both coupled with how do we get the rapidly increasing number of bits to the user. And spectrum, okay, is something that we really need to be working on. And it's not only the spectrum, which hopefully getting more spectrum, looking at how do we do sharing with existing users, how do we do transitions better, between incumbent users and new spectrum. And then finally, the issues of small cells and all of that, and the issues that Tom Sawanobori was talking about, of being able to have a much better way and mechanism of deploying small cells out there so that we can get the value in the cost structure, which really does exist with small cells. We can build a cell for hundreds of dollars today. Okay, that's not the limitation. The limitation is getting the connectivity, such as the backbone of the cell, getting the permission to put it up, getting all of these costs and things like that really under control. Thank you. Let me turn it over to Chih-Lin.
Thank you. I don't think the acoustic is great here, so let me bring the camera.
Equalizers needed.
Okay, Ed said he's going to offer the equalizer that's needed. Good morning, everybody. It's really a great honor and pleasure to be added in the last minute. It's a surprise invitation from Bijan at 4 p.m. yesterday. So if I appear less prepared, please keep that in mind. Anyway, I'm Chih-Lin coming from China Mobile. In addition to the great success story of 4G network in United States, as Tom had shared with everyone, I think really for our industry, we believe 4G is and will be the most successful ever generation in our industry. And China Mobile today boasts basically 1/3 of the total 4G network and 1/3 of the total subscriber of 4G in the world. We have close to 1.5 million 4G base stations, and we have currently about 500 million subscriber out of a total base that we have 830 million, so which means like 60% or so of our subscriber has already upgraded to 4G services. Even with that, we are still, like Tom mentioned, the VoLTE technology. We are deploying it right now. I think over 300 top cities in China already has VoLTE services. Of course, the performance can continue being improved. And we are bringing 3 carrier aggregation into our network, which amounts to total of 60 megahertz bandwidth. And then we are also bringing, a few years back, what's considered a 5G key technology, massive MIMO, 128 antenna base stations into our 4G network, which we did this. I think the first one was installed September last year, so it's more than a year ago now. Even with that, I should share with you, as early as 2011, before we have deployed even the first 4G base station, China Mobile has started thinking about what's next. The reason for that is not only we felt that for sustainability, we need to be efficient and agile. So our keywords 5 years ago was green and soft. Many of you probably have heard me talking about that. And also, since it's the 5th generation of our industry, the 5th time around, based on experiencing other industry, for example, computer industry, we felt for the 5th generation, there is a need to rethink fundamentals through and through. So that's what we started doing 5 years ago. And that helped us in guiding our thoughts and leading us down some of the technology paths. Some has become very fruitful, and some may still stay as a research topic. But some of you may have seen these charts more than once already, because this is basically the foundation of our work in 5G. And also, the first paper that's listed here has the honor of being the first paper in the first IEEE 5G special issue. And we felt that it helped, guided a lot of the work, not only for our company and also for our partners. And of course, this year has been the inauguration year of the 5G standards activity in 3GPP, as many of you are probably, like China Mobile, actively participating. But I think it's very important to recognize that we are at an exciting time of, first of all, I have there CT plus IT plus DT. a true convergence. Actually, even in the 90s or maybe in the late 80s, we have been talking about ICT convergence. But I would say for the past few decades, that convergence has been more or less superficial. But in 5G era, actually starting now, we see the IT and CT technology converge to the bones, at the DNA level, I would say. Great opportunity and challenges as well. But in addition, there is this kind of young DT technology category that has shown up in the right time. So in one shot, I think we are looking at marvelous, wonderful opportunities of all three true convergence. And this is what 5G era will require and will bring us. And for that, I think unlike the previous 4 generations, 5G era requires not only 3GPP to deliver the necessary standards, but also together with IEEE, with IETF, as well as many other SDOs and industry alliances, even taking into consideration of the fast movement of open source community into communication technology industry. I think the forces are there, and the outcome should be beautiful, but we don't know exactly what path we will take yet. And it's up to all of us to use our brain power to figure out how to make sure the traditional SDOs can partner well with the resources in open source community. As an operator, I think requirement and usage scenarios are, of course, very important because we don't want to come up with technology pushing for applications. Rather, we like to have a good feeling of what need there are, and so that we can research and develop the necessary technology to feed the needs. And at the beginning of this year, China Mobile has announced the establishment of the joint 5G Innovation Center, where we have 6 open labs set up. 1 for infrastructure technology, 1 for, no surprise, IoT, another IOV, another industrial internet, another AR/VR, finally, cloud-enabled robots, which is actually something I like to end my brief statement with you, because Bijan had asked me when he extended me this gracious invitation yesterday that to share with the audience our boldest dream of what 5G should bring to us. How many of you have seen the movie Bicentennial Men? That few? Robin Williams, 200 years old, robot. Okay, if you haven't seen that, please go see it. There is an estimation that using current technology to mimic the actual human brain, that system would weigh 1,000 tons today. So certainly, none of an individual robot could possess it. So what's the best way to do it? Put a common shareable brain in the cloud. And our 5G network will provide the necessary nerve system, the connectivity, to your Bicentennial Men, hopefully soon in the future. So I hope that's bold enough.
Yes, I think in the interest of time, I have a bunch of questions, but I would like to give the opportunity to the floor, to the audience to ask questions. Perhaps that would be the best. So, in fact, the floor is open. Are there any questions? Please introduce yourself and pose your question. Okay, please. Yeah, please, yeah. Sorry.
No microphone.
Is there a microphone? Yes, please. Raise your voice.
All the technology is absolutely fantastic, but one of the things that's been on all of our minds recently is the post-truth
Some of my colleagues at the Media Lab work very, very hard on that, actually, in social media. Yeah, the question is the issue with false truths that are floating around online, connecting to people in their wireless devices, actually. And, for me, I see this, a lot of the work that I do in my group is, we use wireless all the time, but we look at how we're living in real and virtual worlds together. We call it cross-reality. Sensor information drives virtual worlds that manifests to people in virtual environments. And we talk about wearable sensory prosthetics, where you can actually wear devices that can plug into sensors all around and really enhance your perception. Look at what you're focusing on, bring that information in. Already, we're living halfway in a virtual world because truth doesn't matter to many people. What appears on here is kind of taken at face value, which I think is part of the problem. We're stillborn. Social media's great promise is to take the best of people and bring it together. And I firmly believe that. It's kind of annealed at this lowest common denominator where the pull to the bottom is very strong. So I think we have to physically work in how we present our content to people. In many ways, it's a UI issue. So that, things that ideally are true or vetted properly, are presented in the right way, that we actually can just eliminate the high pull of highly valent images into things that just are totally false, and bring people up. There are many ways to do it. It's not exactly my expertise, but many people at the Media Lab and institutions everywhere are thinking very deeply about this now. We never thought it would be so deep a problem so soon, but yeah. Truth is, I think, as a scientist, a sacred thing to most of us.
Right. So I think the one challenge, though, in the question that you asked is that truth is very subjective in many domains. So there is facts and there is assessments. We can always comment about facts. It's very hard to comment about assessments, and assessments are highly subjective and therefore can be, can lend themselves to interpretation in multiple ways. However, just drawing it down a little bit, right? So what is the technologies we can do? We already have talked about, we see people thinking about information, what information means. So in order to build networks, to ship bits, instead of doing that, we now have to start architecting and instrumenting networks to ship information, right? So we need to go beyond quality of service. We already talked about quality of experience, but now we need to talk about the quality of information that is being sent, right? How we assess quality of information, it's a little tricky. We need to have social scientists in the loop to figure out what these things mean. However, it's as a network designer, as an engineer in this audience, I can say that don't focus on shipping the whatever bits from one end to another. Think about how I can get the relevant information that's needed from whichever sources are necessary. Right? I think that kind of lends itself to a different model of networks that we see. So we have funded quite a bit of work in this space recently, but again, this is all nascent work. We are very bound by conventional thinking in terms of how networks have to function, what's the role of a network. Again, goes back to the big picture that I was talking about earlier, and goes back to your question, what is our role in this big society, right? If you step back a little and say, how do I ship information? What is what kind of controls and gatekeeping functionalities we need to have before we deliver information? Then we have different design choices we have to deal with. We may not like the choices, but we'll have to face them.
I wonder what Julie has seen at the FCC over the last decade or two as the internet has gone from an idea to now pervasive over wireless and wired. How do you deal with that? What do you face? And is it it's got to be a challenge.
I get, first of all, I'm from the engineering office, so there's obviously the technology raises other policy issues, and I think we, for many of these things, they have tremendous benefits, and at the same time, they also introduce new questions and so forth. And I think there are policies that are examined at multiple layers of government and across agencies. I don't know that I'm the right one to speak to the policy side of that, but obviously this is a new phenomena that I think people are paying attention to.
Are there, okay, question, please. You can stand up and.
Hi, I'm Sonat from Verizon.
Hi.
I guess my question is more towards Julius. By the way, thank you for an excellent presentation and good overview. Facebook recently has shown with their project Tequila and the line grounds that perhaps using unlicensed spectrum and 60 gigahertz band is feasible to provide public cellular service. So in the face of that, as these technologies become technologically feasible or economically viable, what steps will FCC take to protect the value of the spectrum?
Yeah, I don't know how many of you could hear the question, but it really went to new ideas for deploying at 60 gigahertz and unlicensed broadband services and so forth. So the first point I think I'd make is it really reflects the benefit of the flexibility that we provided under the existing rules. Nobody would have thought when we were opening up 60 gigahertz originally of things like higher platforms and so forth. I didn't talk about in my presentation, didn't get to it, one of the challenges we've had in the unlicensed space that we were dealing with within this question of LTE in the unlicensed bands and license-assisted access, and how do you balance the things that created those opportunities, in other words, no protection against harmful interference and that anybody can have access, and make sure that you don't harm all of the things that are there already. And I think the formula that has worked so well has been the efforts by industry, academia, in trying to make sure all of these things work together. Whether that new technology turns out to be successful, that's terrific, and let's see where it goes. But what we're always trying to balance is that we maintain the opportunity to do those things without harming the incumbents, even though they're not technically protected against harmful interference. My inclination is it's probably not a problem, and to go into these things starting with the presumption that if everybody is doing their job and sharing the spectrum fairly, things will work, as opposed to going in and assuming there's going to be problems.
Any questions from the audience? Yes, please.
My question is actually about the future of wireless. So it seems like we are locked onto three possible dimensions of capacity expansion: millimeter wave, densification, and mass demand. If we put them all together for the next 5 years, maybe we can have all the time capacity gain, but demand is exponentially rising. So what will happen after 5 years? By the time we will have that much capacity, we will already be outrun by that, particularly with the type of application MIT Media Lab is coming up with.
Yeah, I can take that. The question was, the demand by consumers for data is growing so rapidly. How will the things we're talking about now be handled? We're maybe looking too short term. And I think the point's well taken, and I think you see the equipment providers working very hard to get several times increase in capacity, but as we've seen, the applications will demand more. We don't know what they'll be. But I think you saw some of it in Julie Knapp's keynote, where he talked about going above 100 gigahertz. The FCC wouldn't talk about that many years ago, but now you look at frequencies above 100 gigahertz, and there's just such vast spectrum. So I think we're talking 50, 100 gigahertz of wireless spectrum being available within the next 10 years, and that will quench the thirst of the new applications.
Just to add to that, in the short term, over the next 5 years, we're going to need to continue to do what we've always done, which is to deploy additional spectrum. So additional spectrum bands like AWS-3, Julie mentioned. There's an extended action going on right now. There's a 3.5 gigahertz spectrum. We're working with folks in 3.5 gigahertz CBRS Alliance to make equipment available for that. And if you think about, a lot of the usage is occurring indoors, so we need both outdoor deployments and densification as well as indoor deployments, along with technology improvements. So I think you're going to need a combination of all these things. And then longer term, as Ted mentioned, we'll need access to the millimeter wave technologies and really the gigahertz quantities and levels of spectrum.
So, I mean, in order to imagine the future of wireless, you really need to imagine the future of communication. So our human eyes are the highest bandwidth sensory input that we have, and the best you can do is video, right? Think of 4K immersive video. I mean, you don't need any more fidelity than that. At least your brains can't handle it. Once you go past video, what else left? Right? Let's assume you're immersed in 24/7 video all the time. That's essentially the upper limit of human communications need in some sense. If every single human being had an AR glass on them and they're non-stop watching video 24/7, that's apart from sleeping hours, right? That's your upper limit of human capacity. However, now we can talk about machines needing to talk between themselves. Then we are in a totally new world. We still don't know, right? Now, the challenge at that point is whether the machines will need us or we will need the machines. So,
You'll also heavily leverage context too. So ideally, these nodes are going to send information when they need to and not just chatter all the time.
Right, exactly.
And maybe, when I started out the presentation this morning, and we're a good way to wrap this, is, we've had these questions since people started dealing with spectrum. We're going to run out of spectrum. How are we ever going to accomplish meeting the growing needs? And we always manage to find a way. And as I look down the road, I'm really not worried about what's going to happen in 5 years. Some of the things we talked about, you have to stay ahead in the spectrum game because you don't know, I don't know what's going to happen in 5 years. Sometimes I'm not sure what's going to happen next week. Who predicted the phenomena, for example, of the Pokemon Go or VR and how that might change things? So I think what we're seeing is kind of a revolution in technology advances that let us pack more and more into the spectrum space, and to keep expanding the space. That was when I talked about 30 megahertz being the upper range for mobile. Actually, when I went back earlier in my career and read the papers from the commission, that's what they thought was the highest. and so we keep expanding what we're squeezing out of the spectrum, and I think I'm absolutely confident that as the applications and densification grows, that we're going to be able to address these needs.
Well, we had a very interesting panel yesterday, millimeter wave versus sub 5 gigahertz massive MIMO. The intention from the organizer or the moderators, Robert Heath and Tom Mazzetta, was for the blue team and the red team to fight it out. But we believe that actually everyone agreed that these two technologies are not mutually exclusive. Massive MIMO can apply to sub 5 gigahertz as well as it's basically taken for granted in the millimeter wave as well. And millimeter wave will have great opportunity sometime down the road when the device technology, the material, and all of that gets progressed to the next level, because currently it's still kind of expensive. But we believe millimeter wave, with its advantage of wide bandwidth, will play a big role in kind of a localized environment, be it indoor or outdoor. Whereas when you need coverage and mobility, which is essential in our industry, probably would still rely mostly on the lower band. And as far as UDN, actually, I would challenge you to give a precise scientific definition of what amounts to ultra-dense network. It's kind of arbitrary. Yes, we are getting denser and denser because densification has helped our industry greatly. But can you imagine, we already know when the cells shrink to a certain level because of the interference coordination management, we probably should go to kind of the C-RAN, Cloud RAN architecture to coordinate them together. In addition, if you imagine a even more significant scale change in the sense that typically per cell, per AP, you are talking about maybe 100 or 200 users. Now, if the user to AP ratio continue go down as you densify to the level of almost 1-to-1, or even in some environment at some time, it's less than 1-to-1, then you are talking about ultra-dense, I think. But right now, I don't think that there is a quantified definition of UDN. UDN is kind of conceptually qualitative description. But there's an interesting thing to look into when you have significant change in the ratio of the two, I think.
Ted, you would like to add anything?
Let's go to the last question.
Okay, Inder, you have a question? This is the last question.
5G tries to do many things, and I'm questioning if that makes sense. IoT and field communication have very different characteristics. So why not build a separate network only for IoT?
I'm not a 5G expert, they're here, but I do believe we'll have a tiered radio structure where certain bits that get sent very infrequently or at very low power may not be for 5G, but I'm willing to be proved wrong.
As operator, I am obliged to answer first, okay? That question, okay. Certainly, technical feasibility aside, for survivability of and the sustainability of our industry, it's a path we must take. In the sense that for the previous 4 generations, we have been continuous turbocharging basically a horizontal platform for folks like us. We were a B2C primarily. But we all know, folks like us, we like better, higher, faster, all the good things continue to improve. However, any of us are willing to pay proportional to that the performance and function improvement that operators are providing to you? The cost is going up, but the revenue is not proportional to it. I think we all know. That is why 5 years ago, we have, not counting the vendors in China, just the rest of the world, we have, 6 to 8 choices. Today, if you don't count the 1 or 2 in China, how many do we have to choose from? The 10, the vendors, we have 2. What does that mean? Our industry is in crisis, or will be in crisis, if we don't change our mindset. So for 5G, in addition to continue turbocharging the horizontal platform, we have to be able to utilize the same infrastructure to embed in multiple vertical platforms, which each one may target very different service needs.
Okay, I guess in the interest of time, are there anything, in fact, okay, please, quickly then.
Yeah, I just wanted to say the real issue is cost, okay? And you mentioned IoT. IoT has a huge range of use cases, all from the meter reading case where I may have to dip at the meter once per month, okay, to stuff that's actually a significant and sizable amounts of data. So what we want to do is to really fundamentally try to have one platform, okay, which then has the ability to sort of adjust for all these use cases. And this is a challenge for the designers in 3GPP. It's also going to be a tremendous challenge also to the implementers to get the cost structures down. But one of the challenges that we already have today is fundamentally cost structure for the low-end devices. Yes, you can go to things like Wi-Fi, but Wi-Fi tends to do very incremental enhancements, improvements, and has a whole bunch of other issues as part of it. So the reality is, if we're talking about just like China Mobile has 1.5 million cells, and we're probably going to be going up beyond that as we get into 5G and the higher data rates, just from the perspective of getting coverage, okay, at high data rates. You know, we're talking about many millions of cell sites, you know, in a large country. You know, we have to think about universality and ubiquity of one fundamental network.
Okay, I guess
Just go finish up a few points.
Very brief then.
Yes, yeah. So, I mean, there are already IoT networks. LoRaWAN is out there. right? Your Wi-Fi network at home is mostly IoT. You don't use it that much. Your devices use it more than you, right? So you already have those things out there. Now, 5G operators clearly want a slice of the IoT ecosystem. Therefore, they are developing something, and the cost considerations and others go into play there, which is why whether it will work or not, that remains to be seen. The standards will tell us, and the adoption will tell us. I'll give you one thought experiment to, for all of you to consider before you leave. Imagine there's a bunch of hotspots all around DC, in this building or everywhere. Imagine all of them had the exact same SSID, that you don't have to sign into anything. You can walk around, right? This is your example of an ultra-dense network that's already out there. If you can solve that challenge, 5G is already here, okay?
So I guess since Dr. Tarak was a keynote speaker, so we can give the last question to him, please.
I have a question for Dr. Mapar. I know the Department of Homeland Security has a lot of experience in system design. How do you feel that experience and knowledge can be kept in wireless design for 5G?
You really cornered me, didn't you? I was just mentioning that to Julius. I will be very brief. Just give you the nuggets. Why are you worried about spectrum? You know, when it shows up, you find something else. System of systems. Who thought 20 years ago that we'd have to worry about how the systems operate? We don't even understand the systems. We don't understand the interdependencies. Approach them, deal with them as you find out about them. Giving you sort of lessons learned, if you will, what we are finding. And even if you talk to the research community, talk to NSF, talk to the universities, MIT Media Lab, anybody you talk to, necessity is the mother of all inventions. As you get to these problems, you'll be creative, you'll find problems. You're running out of bandwidth, you'll find another way of finding it. Why worry about it? 50 years ago, think about the critical infrastructure that we have that we're finding now, we see the analogies. The metro system in the DC area was designed about 40 years ago, 50 years ago. It's overcapacity, and they're fixing it right now. What does that tell us? What that means is if you're thinking about the future of wireless, please, please, please think about security now, not an afterthought. Everybody is getting so excited about 1G, 2G, 5G, LTE, this, that, and so on. They're just moving ahead exponentially. But guys, remember, we've got some lessons learned from the internet, right? We're worrying about those day and night. As we learn about our systems in the critical infrastructure, we got so many wireless devices in the electrical grid. We've got SCADA, we've got GPS, reliance on GPS. Anybody can spoof that signal. These are the things that we're worrying about. We've got about 2, 3, 4 million first responders, fire, hazmat, et cetera. When they go into a tunnel, their radios don't work. Where is the future of wireless in that? 700, 800, 900 megahertz radios, interoperability. The devices are just exponentially going up. Even if you start to think about what does that mean, we still don't know. Let's deal with it as we find out. I'm sure NSF is doing basic research on that, Those are some of the things that we're trying to figure out. So let's not spend so much time trying to see what the future will hold. Just go step by step and deal with it as you learn more about the system. That's our lesson.
Okay. And with that, I would like to close this panel. The panelists will be around, so if you'd like to ask questions and so forth, you could do so. But let's give a round of applause for all the panelists.